Section 4.3, Quadratic Inequalities. In this section, our goals are to determine, what is a quadratic inequality and how to solve quadratic inequalities graphically and algebraically. And we'll look at a couple of applications. A quadratic inequality in one variable is an inequality which can be written in the form ax squared plus bx plus c is greater than 0, where a, b, and c are real numbers and a is not equal to 0. The greater than symbol may be replaced with less than, greater than or equal to, or less than or equal to. Alright, so here we're going to learn how to solve a couple of quadratic inequalities. We're going to look at a graphical technique. So we're going to solve the inequalities by hand and show a rough sketch of the graph that helps us solve the inequalities. So I'm going to think about the graph of y equals ax squared plus bx. Well, I have specific values here. X squared minus 5x minus 14. Now, I know that this is going to open up, but I really want to focus on where it crosses the x-axis. So to do that, I have to find the x-intercepts. So x squared minus 5x minus 14 equals 0. Let's find x-intercepts. Now this factors as x plus 2 by x minus 7. So then x plus 2 equals 0, which means x is negative 2. X minus 7 equals 0, which means x equals 7. So I have x-intercepts at negative 2, 0, and 7, 0. So if I plot those points, here's negative 2, 0, and here is 7, 0, and I know I have a parabola opening up. So I'm just going to draw a rough parabola. This is a very poorly drawn parabola, and it's going to do something like that, okay? I'm not too worried about the specifics. I don't need to know where the vertex is for this. I don't even really need to know where the y-intercept is. I need the x-intercepts and whether it opens up or down. Now, where is x squared minus 5x minus 14 less than 0? Well, I see that all of these points that I'm shading in blue on the curve have y values that are less than 0. So, smashing that to the x-axis, here is the interval of the solution. The solutions go from negative 2 to 7. Now, since it's a less than inequality, we cannot include the endpoints. So we say from negative 2 to 7 in parentheses on each of those endpoints. Where is x squared minus 5x minus 14 greater than or equal to 0? Well, all of these points have y values greater than 0. All of these points have y values greater than 0. Smashing those to the x-axis, I get this interval and this interval. So, the interval goes from negative infinity to negative 2. Now, since it's an or equal to inequality, I will bracket it. Union, what about the other part? It starts at 7 and goes to infinity. So, if we want to solve an inequality, a quadratic inequality, where it's less than or greater than 0, we first find where it's equal to 0, draw a rough sketch, and shade the appropriate regions and convert those to intervals. Here's another example. Here we have x minus 5 squared is less than or equal to 0, x minus 5 squared is greater than 0. So let's think of the graph of y equals x minus 5 squared. I know it opens up. Now, with this one, if we think of it in terms of shifts, if we think of it as its vertex form, I know it's only shifted left 5. I'm sorry, it's shifted right 5. So that puts the vertex at 5, 0, and it opens up. Right? So I get, roughly that. All right, so now, where is the x minus 5 squared less than or equal to 0? Well, it's never less than 0. Is it ever equal to 0? Well, it's only equal to 0 at this one point. So x minus 5 squared is less than or equal to 0 only has one solution at x equals 5. Where is x minus 5 squared greater than 0? Well, basically, it's greater than 0 everywhere else. Right? Everything up to 5, everything after 5. So negative infinity to 5, parenthesis, union, 5 to infinity. All right, here we're asked to solve the inequality using a calculator, round any endpoint to 2 decimal places if necessary. And we have negative 11x minus 16.562 is less than x squared plus 0.49x. All right, so what I'm going to do here is I'm going to get one side to 0, and I'll do that by subtracting x squared from both sides, and I will subtract 0.49x from both sides. So then that would give me equivalently negative x squared minus 11.49x minus 16.562 is equal to 0. Now what I'm going to do is I am going to graph this on the calculator. Graph this as y equals, and I'm going to find the endpoints by finding the x-intercepts. All right, so let's see what we have. We have y equals, clear that out, negative x squared minus 11.49x minus 16.562. Make sure I punch that in right. Check my window. I'm in the standard window. Let's see what that gives me. All right, I see most of it. Let me just change my window a little bit. Let me go from negative 15 to 5 on the x's. And for the y's, we can go from negative 10 to, how about, let's go to 15 on the y's as well. And that gives me a better graph. All right, let me grab this real quick and put it on the screen. All right, so here is that graph. Now basically what I'm focusing on is I want to find these x-intercepts first. I want to find these zeros of the function. And then I need to solve where is negative x squared minus 11.49x minus 16.562 less than 0. So then we'll be able to find those points. All right, so let's find the x-intercepts first. All right, so using the calculator, let's calculate, use the 0 command. Let's go and find the first x-intercept way to the left. All right, so I'll use as my left, I've got my left boundary. I hit enter, move to the right, go past it, hit enter a second time, and go towards it, hit enter a third time, and it's negative 9.8. All right, so this point right there is negative 9.8 comma 0. Let's find the other one. Calculate 0 command. All right, left boundary, hit enter, move past it, hit enter a second time, move towards it, hit enter a third time, and negative 1.69 comma 0. All right, so this is negative 1.69 comma 0. Now, we were solving negative x squared minus 11.49x plus minus 16.562 is less than 0. So that would be this part of the quadratic function, and this part of the quadratic function. So smashing those to the x-axis, it would be this part of the interval and this part. So then the solution would be negative infinity, comma, negative 9.8, union, negative 1.69, comma, infinity. So we've been using a graphical point of view to solve these quadratic inequalities, but now let's use a symbolic point of view, algebraic. So here we're asked to solve 4x squared minus 9 is greater than 0. So an approach is to first solve the equation. So let's solve 4x squared minus 9 equals 0. Now I look at this and notice that there's no x term, so I'm going to use the square root property. So I got 4x squared equals 9, which means that x squared equals 9/4, which means that x is the positive or negative square root of 9/4, so then x is positive or negative 3/2. Alright, so now what I'm going to do is, in a sense, I'm going to take my number line and I'm going to break it up into 3 intervals. So here's my number line, and I'm going to put 2 important values on it. Negative 3/2, positive 3/2. And now what I'm going to do is I'm going to test points. I'm going to test a point in the first interval, the second interval, and the third interval, and I'm going to test them in the function 4x squared minus 9. Alright, so let's choose a number less than negative 3/2. So how about negative 5? Alright, so if I test negative 5, then I would have 4 by negative 5 squared minus 9. Alright, so that's 4 times 25, that's 100 minus 9, that's 91. Alright, so 91, that's a positive number. See, now remember, we're comparing, we want to compare to 0, right? That was our original statement. We had compared to 0. So this ends up being positive. If x is negative 5, we get a positive. Alright, well, what if x is somewhere between negative 3/2 and 3/2? Let's use 0. 4 times 0 squared minus 9, that's 0 minus 9 is negative 9. A negative. And in the third interval, let's use 5. 4 times 5 squared minus 9, that's 4 times 25, that's 100 minus 9, which is 91. And so again, I get a positive here. Now, I wanted the 4x squared minus 9 to be greater than 0. I want the 4x squared minus 9 to be positive. So where are the solutions? In this part of the number line and this part of the number line. And so we write the solution. I'm going to use interval notation. So the solution then is negative infinity to negative 3/2 union 3/2 to infinity. Alright, here's another example. We want to solve algebraically. 2x squared minus 8x is less than 3x minus 12. Alright, so I'm going to get this to a standard form. I will subtract 3x from both sides and add 12 to both sides, yielding 2x squared minus 11x plus 12 is 0. Now let's see, I'm not sure if that's going to factor. So let me just go straight to the quadratic formula. And so, now this is originally a less than, I got to remember that this is a less than inequality, but what I'm thinking here is I'm going to first solve the equation. Equals 0. I'll use the quadratic formula. So x would equal 11 plus or minus the square root of 11 squared is 121 minus 4 times 2, that's 8. 8 times 12 is 96. Over 2 times 2 is 4. So that's 11 plus or minus the square root of, let's see, 121 minus 96. is 25 over 4. So that's 11 plus or minus 5 over 4. 11 minus 5 is 6. 6 over 4 is 3 halves. 11 plus 5 is 16. 16 over 4 is 4. All right, so now, there's my first step. I've solved the equation. Now let's consider the inequality with a number line. All right, so here's my number line. I'm going to put 3 halves on the number line. I'm going to put 4 on the number line. And I'm going to test in 2x squared minus 11x plus 12. All right, so what should we test? A number less than 3 halves. Well, let's test 0. If we test 0, then we'd have 2 by 0 squared minus 11 by 0 plus 12. That's easy. That's 12, which is positive. All right, so now let's test a number between 3 halves and 4. How about we test 2? 2 times 2 squared minus 11 times 2 plus 12. And that's 2 times 4, that's 8 minus 24 plus 12. 8 minus 24 is negative 16. Negative 16 plus 12 is negative 4. Negative. And we test one more point, some number greater than 4. How about we test 5? 2 times 5 squared minus 11 times 5 plus 12. That is 2 times 25 is 50 minus 55 is negative 5. Negative 5 plus 12 is 7. Positive. All right, now again, we were solving 2x squared minus 11x plus 12 is less than 0, which means we want the intervals that came back with negatives. And so we would only shade maybe this part of the number line, which is between 3 halves and 4. So therefore the solution is from 3 halves to 4. All right, so we want to solve algebraically, where is negative 2 minus x squared less than 0? All right, so let's see. Let's first consider, let's try to solve. Negative 2 minus x squared is equal to 0. All right, so let's see. That would mean that negative 2 equals x squared. So no real solutions. All right, no real number squared can be negative 2. So when we consider our number line, we can't put any boundaries here. So we just need to test once. Let's test into negative 2 minus x squared, and we can test any value. So I'm going to test 0. Negative 2 minus 0 squared is negative 2, which is negative. So what that tells me is, see, there's no boundaries here. The sign is never going to change, and the whole thing ends up being negative. So I wanted negative 2 minus x squared to be less than 0. I would shade the entire number line. And so then my solution is the set of all real numbers, negative infinity to positive infinity. All right, let's consider a couple of applications. First, the height in feet of a baseball after t seconds is given by the function h of t is negative 16t squared plus 108t plus 3. During what time interval is the baseball at least 140 feet in the air? So at least means greater than or equal to. So we want the height, we want h of t to be greater than or equal to 140. So then negative 16t squared plus 108t plus 3 is greater than or equal to 140. And now we want to solve this inequality. Like before, the first thing I'm going to do is put this in a standard form. I will subtract the 140 from both sides. So then negative 16t squared plus 108t minus 137 is greater than or equal to 0. So first I'm going to solve the equation equal to 0. I'm going to apply the quadratic formula. Using the quadratic formula, x would equal, not x, but t negative 108 plus or minus the square root of 108 squared minus 4 by negative 16 by negative 137 over 2 by negative 16. All right, so let's use the calculator here. Parentheses for the entire numerator. Negative 108 minus square root 108 squared minus 4 by negative 16, close, open, negative 137, close the 137, close the radical, close the numerator, divide by 2 times negative 16, I'm just going to do that in my head, negative 32. Hit enter. Alright, so there's one of the values. Let me second enter. Let me change that minus to a plus. So we have 1.69 and 5.06. So now we have those, and I'm going to use a graphical point of view here. So if we think of this inequality, we now know that if I was to graph y equals negative 16t squared plus 108t minus 137, if I was to graph that, it has x-intercepts at 1.69 and 5.06. I also know that it opens down. So a very rough graph gives me this. Now, I want to be greater than or equal to 0. So that would be this part of the graph, which smashes down to this part of the x-axis. Conclusion. The ball is at least 140 feet in the air from 1.6 seconds to 5.06 seconds after it is, let's assume that it was hit, after it was hit. All right, so on that time interval from 1.69 to 5.06 seconds, the ball is at least 140 feet in the air. All right, one more application. A company sells personalized pens at 480 minus 20x per month when they charge X dollars per pen. All right, so they charge whatever they charge per pen. The company's going to sell 480 minus 20x pens. The company wants their revenue from the pens to be over $2,160 per month. All right, so we want to determine a revenue function R of X for the pens. Well, revenue is price times number sold in this situation. All right, so revenue is going to be the price times the number sold. Well, the price, that much they charge, that's X. The number sold is 480 minus 20X. Or, using the distributive property and changing the arrangement of the terms, negative 20x squared plus 480x. Part B asks us, in what range should the company price the pens to keep the desired revenue? They want the revenue to be over $2,160 per month. So we want the revenue, R of x, to be greater than 2,160. So then negative 20x squared plus 480x needs to be greater than 2,160. Putting that in a standard form, negative 20x squared plus 480x minus 2,160 is greater than 0. So now we want to solve this. Let's see, I'm going to apply the quadratic formula, thinking again of the equals 0. Quadratic formula. So then x would equal negative 480 plus or minus the square root of 480 squared minus 4 by negative 20 by negative 2,160 over 2 times negative 20. Again, I'm going to use a calculator here. Negative 480, lost the negative. Let's start over. Negative 480 minus the square root of 480 squared minus 4 by negative 20 by negative 2,160. Close off that, close off the radical, close off the numerator, and divide by negative 40. 18 and plus 6 and 18. So x is 6, x is 18. All right, so now, again, if we kind of think graphically, we again have a parabola opening down. Here's 6 and here's 18, and very roughly we get a parabola doing this. All right, because we have a negative 20x squared, so the parabola opens down, and we want above 0. We want greater than 0, so we must be in this part of the graph, which means our values for x must be between 6 and 18. All right, so the company should charge between $6 and $18 per pen. All right, that concludes the presentation for section 4.3.